In this question, they are asking drive an expression for the internal resistance of a cell in terms of EMF, terminal potential difference of a cell. So this is very easy question. So what we will do, we will first take a cell. First we will take a cell, and this cell have the internal resistance R, and this cell have the EMF E. Okay, this cell have the EMF E, internal resistance R, and suppose this cell is connected with an external resistance capital R. All things we have discussed. Okay, and suppose this cell is in the working condition, so current is flowing like this. Current is flowing like this from the positive terminal to negative terminal. So we have to prove this thing. V is equal to E minus IR. I have told you earlier about this, but I have not told you the proof of that, from where this formula came. Okay, today you will know from where this formula came. Okay, so what you have this circuit, you have this cell of EMF E, internal resistance R, and this is external resistance. So what you will do, you will choose points like this: A, B, C, and D. Okay, A, B, C, D, and current is flowing like this.
Yes, sir.
Current is flowing like this, and what is the potential difference across this R? This will become IR. If I current is flowing, this will become IR, potential difference across this R. Okay, so now we will apply Kirchhoffs voltage law. Apply
Kirchhoffs voltage law.
Kirchhoffs voltage law. When you will apply, so how we will apply Kirchhoffs voltage law? We will choose any path. Okay, so Harsh, which path do you want to choose?
Sir, A, B, C, D, A.
Okay, very good. A, B, C, D, A path you have chosen.
Yes, sir.
Okay. Now, when moving from A to B, you are moving in the direction of current.
Yes, sir.
So you will take this IR positive or negative?
Negative, sir.
Very good. Now from B to C, there is no cell or resistance, so it's okay.
Yes, sir.
So from C to D, there is a resistance, internal resistance. Here the potential drop or the potential difference will be IR, and we will take it as negative
minus IR.
I into small r. And
so
now
plus E.
Yeah, plus E we will take. Why? Because we are moving from
lower to higher potential.
Lower to higher. So plus E. Okay. And okay, now take minus common. When you will take minus common, or you can do this. E is equal to, you can write this IR plus I into small r. Okay, and this IR is equal to V.
Yes, sir.
This IR is equal to V, and this is small r. Now you can write V is equal to E minus IR. So this is the condition. This is the condition of discharging of cell. Okay. So this is the way to prove that.
Yes, sir.
By applying the Kirchhoffs voltage law, we can prove that.
Yes, sir.
So now I will take this question. This question is looking very big, but this question is very, very easy.
Yes, small.
Just make it small. Okay. So first read it. They are saying that
the reading on a high resistance voltmeter when a cell is
I am reading. Just I'm reading. So they are saying the reading on a high resistance voltmeter when the cell is connected across it is 2.2 volt. when the terminals of the cells are also connected to a resistance of 5 ohm as shown in the circuit, the voltmeter reading drops to this. Find the internal resistance of the cell. Just see this, what I am doing. First they are saying you have a cell and you have connected this cell with a voltmeter. Okay, you have connected this with a voltmeter. So when you will connect the cell with the voltmeter, there is a reading on the voltmeter that is 2.2. Reading on voltmeter is 2.2 volt, and this 2.2 volt reading will be the EMF of this cell. Why this is the EMF of this cell? Because there will be no drop of potential. Okay, because there will be no drop of potential because you have just connected the voltmeter. Okay, so the voltmeter will measure the EMF of this cell. Okay, EMF of this cell. Now what they are saying that when the terminals of the cell are also connected to a resistance of 5 ohm shown in the figure, the voltmeter reading drops to this. Now suppose you have connected, I am taking the second case, second condition I am taking. Suppose now you have connected this with a 5 ohm resistance, and here this is the switch you have connected. So this time the reading of the voltmeter changes. The reading of the voltmeter becomes 1.8 volt. 1.8 volt. And now this 1.8 volt, is telling the potential difference across this 5 ohm resistance. Okay.
Yes, sir.
Why this is telling the potential difference across 5 ohm resistance? Because you have a cell, and this cell you have connected with the load, and now this cell will be in the working condition, and there will be some drop of potential, and that potential drop will be measured by this voltmeter. What is the use of voltmeter? Voltmeter is used to calculate or used to find the potential difference.
Potential
Okay,
difference.
and this 1.8 will be the potential difference across this 5 ohm resistance.
Yes, sir.
So this is the potential difference across this 5 ohm resistance, 1.8 potential difference across this 5 ohm resistance. So you can just find out the current flowing here.
Yes, sir.
And one thing you should know, that the current in this direction will almost equal to 0. Okay, because
Okay.
in voltmeter there is a very small negligible amount of current flows. Okay, when you
Yes,
connected
sir.
the voltmeter, so the current flow is small. So here there will be no current, you can assume, as very small amount of current will flow that you can neglect. So you can say that the current flowing in the circuit is like this, means current I is flowing here, I is flowing here. Here is the branching. The current should change. But why the current is not changing? Because all of the current is going through this path. Okay. Okay, fine. So now you have can you calculate the current from
Yes,
V
sir.
is equal to
V is
IR?
equal to IR.
So what is V? V is equal to 1.8.
1.8 is equal
And
to I into 5.
I into
I is
5.
equal to
1.8
1.8
divided by 5.
5.
So this will become 9 by 25 ampere.
9.25 ampere.
Ampere. 9
Yes,
by
sir.
25 ampere. Now they are saying, what they are saying? They are saying find the internal resistance of the cell. We have to just calculate the internal resistance of the cell. Here somewhere will be the internal resistance R of the cell. Okay.
Yes, sir.
Here somewhere will be the internal resistance R of the cell. This is positive terminal, this is the negative terminal. Okay. Positive and this is negative. So internal resistance, and you know that this cell this time is in the working condition, means
Yes.
this cell is discharging. So you know the equation of discharging, V is equal to E
EIR
minus
minus IR.
IR. What is B? Already given 1.8,
Potential. Yeah.
and E already know 2.2,
Yes.
and I already know 9 divided by 25,
925
and this is R.
internal resistance.
This is R. So can you calculate this R now by
Yes,
yourself?
sir. Yes, sir.
Because this is just the calculation part, so you can do it easily. Okay.
Yes.
When you will what you will do, you will subtract this from this, and then you will get the answer.
Yeah. Yes, sir.
Now now this question. This question is also looking very typical, but this is very easy question. How this question is very easy? They are saying calculate the steady current through a 2 ohm resistor in the circuit shown. So 2 ohm resistance, this is the 2 ohm resistor. Here
Yes,
we
sir.
have to calculate the current. So here one capacitor is connected. One capacitor is connected. This is the capacitor.
Yes, sir.
Okay. So what will happen? This is the DC circuit. This is the DC circuit. Okay. DC circuit we have. We have cell.
Yes, sir.
This is the cell, and cell provides the DC current.
Yes, sir.
Okay. So what happens in DC circuits? There will be no current passing through the capacitor, or you can write capacitor offer the infinite resistance for DC circuit. Capacitor offer the infinite resistance in DC circuits. And why this happens? Because see one thing. Now see here. In DC circuit, what happens? There is a charging process of capacitors. When the capacitor is fully charged, there is no flow of charge from one plate of the capacitor to the another plate of the capacitor. Means there is a no flow of current between the plate of capacitor.
Yes,
Okay.
sir.
There is, so from here, means in this wire there will be no current.
Yes, sir.
If in this wire there will be no current, means we can throw this wire out.
Yes, sir.
Okay, now I am throwing this wire out. So we have this circuit now. This 2 ohm only we have, and this 3 ohm only we have. Why I have thrown this wire out? Because in DC circuit there will be no current in the capacitor. Simple. Okay. Otherwise you will get confused. You cannot solve this question if you don't know in DC circuit there will be no current in the capacitor. Okay. And what we have now? We have here a 6-volt battery and 2.8 ohm resistance. 2.8 ohm resistance. Wait. ohm resistance, and this is 2 ohm, this is 3 ohm here. This is 2 ohm, this is 3 ohm here. We have already discussed this kind of question, but I am just telling you again. Can you find the equivalent resistance of the circuit? Suppose the current flowing I in this direction,
Yes, sir.
like this. So, how we will find the equivalent? First, find the resistance across A and B. When
Yes,
you will
sir.
find RAB, you will write this 2 into 3 divided by 2 plus
2 plus
3.
3,
This will be 6
6
by 5
by
ohm.
5. Yes, sir.
And if and the equivalent of this is 6 by 5, you now
Yes,
you
sir.
will add this into 6 in 6 by 5, you will get the equivalent
Yes, sir.
resistance. Equivalent resistance, you can write 6 by 5 plus 2.8 you will get, and from here, so you will take the LCM here 10, so this will become 12 and this will become 28, and 28 and 12 is, so this will become
So
40
40.
divided by 10,
Then it will 4,
this is
sir.
4 ohm. So the
Yes.
equivalent resistance of the circuit is 4 ohm.
Yes,
Equivalent
sir.
resistance of the circuit is 4 ohm. Okay, very good. Just calculate the total current. Just calculate this current I. What is this I? I is the and we have one thing more, na? We have this 6-volt battery, 6 volt,
Yes, sir.
6-volt power source. So what you will write? You will write this. Okay, means E divided by, means equivalent EMF divided by the equivalent resistance.
Yes, sir.
So this is I is equal to, what is the equivalent EMF, or you can say equivalent potential
6, sir.
difference,
6.
6. Right here instead V. V is better. This is 6 and R equivalent is 4.
4.
6 by 4, this
2.
is 3.2,
3. Yeah,
this is
sorry.
1,
Yeah.
1.5. So current in the circuit is 1.5 ampere. This is 1.5 ampere current we have. So now let's see. This 1.5 ampere current will flow here also, here also. Okay. This 1.5 ampere current will flow through this resistance also, and
Yes, sir.
through this circuit, through this whole circuit, through this whole circuit, the current of 1.5 ampere will flow. So this is the circuit we have, and in this circuit, means this is a point A. Now I am just taking a part of that circuit, and we know what the value of current. The value of current flowing here is 1.5 ampere. But we have to calculate the current in this 2 ohm resistance. So for that, we should know what is the potential drop across this. Okay. For the potential drop, what you will do? For the potential drop, what you will do? This 6-volt voltage, this 6-volt voltage is divided among this and this. Okay. This 6-volt voltage will be divided among this and equivalent of this. Okay. So you can write this 6 volt is equal to, what is the voltage drop here?
2.8.
2.8 into I.
Yes, sir.
Okay. So right here instead. So voltage drop, you can write here like this: 6 volt is equal to VAB, means across AB. This voltage is spending across AB and spending across this 2.8 into I, VAB plus this 2.8 into, what is I? I is 1.5 So from here you will get this VAB. Can you calculate this VAB for me?
Just a sir.
Okay, fine. Just multiply all the things.
Yes, sir, and then divided by 6. Just a minute,
Okay, okay. Not divided by anything. You have to subtract here, no? Not divide.
Oh yeah, it's subtraction.
This will become 4.2.
Yeah, it will
6 minus 4.2 you will get. You will get
yes, 1.8.
1.8. Very good, Arjun. So now you can see the voltage across AB is 1.8 and these both the resistance are connecting in parallel.
Yes,
So
sir.
this 1.8 volt will be here. And here also the potential drop will be 1.8 volt because this is a parallel combination.
Yes, sir.
Now we can find the current across this. Okay, current. So you can write here across 2 ohm. The current will be I is equal to V by R. V by R. What is V across 2 ohm? 1.8.
1.8
divided by 2. What is the answer? 0.9.
0.9
ampere. So the current will be 0.9 ampere you will get.
Yes, sir.
This is your final answer. So I will say mark this. Okay, just I'm changing my pen. Not this. I will say mark this as the 1 star because this is typical question. I will say, and you can do this easily. This is not a big deal. And I will say this question is easy. We have already solved these kinds of questions. So this question I will say is the star of today.
Yes.
Okay. So just would you like to take the screenshots or?
Sir, as you say.
Actually, we have to save our time. So
yes,
I will
sir,
say that.
screenshots.
But when we will discuss our topic, then I will give you the time for noting down. Okay.
Yes, sir.
This is the assignment discussion. So here we can save our time. And
yes,
this question you can get you can already get this question on the portal.
Yes, sir.
Okay. If you will write this question again and again, then what is the use of that? Okay. Just
yes,
I am
sir.
zooming it out and just note the question down. And believe me, Harsh, you will get similar questions in your exam.
Yes, sir. So can you zoom out more so can I get the
Zoom
full
out.
answer?
Yeah.
Yes,
Now
sir.
it's fine now?
Yes, sir. Yes, you can scroll down. Next question.
Okay, fine.
Yes, you can scroll down. A little bit more, sir.
Okay.
Good answer. Next question, sir.
Mark this as a star, okay? And revise
Yes,
it. This will be maybe this will appear in your exam.
Yes, sir. Let's move to the next one. Next.
Is it fine now?
Yes, sir.
Okay, take this.
You can scroll down.
Yeah.
Done, sir. Okay.
And one thing here, this is just I am telling for the interest of physics. We don't know what is the voltage across. It will take at least 5 minutes.
Sir, we'll start the next chapter, right?
Today?
Yeah.
Actually, we have 2 or 3 small topics. Then we will start the next chapter in the next class.
Okay.
I don't think it. Okay, no problem. Just this is the question that we have to solve.
Calculate equivalent resistance across diagonally opposite
This
ends.
question is looking complicated, na?
Yes.
Okay.
No,
problem.
wait. It is not complicated.
It is a very easy question. Just see this. Actually, we are just now. The topic is equivalent resistance using Kirchhoffs law. Just write the heading: equivalent resistance using Kirchhoffs law. And what is the equivalent resistance? We have calculated the equivalent resistance many times. Equivalent resistance is equal to total voltage divided by the total current.
Yes,
Simple.
sir.
So this funda we will use here to calculate the equivalent resistance. Okay.
Yes, sir.
Just okay. So just see this how I will solve this question. So they are asking calculate the equivalent resistance across the diagonally opposite end. So you can choose any of the diagonally opposite ends. So diagonally opposite end. Just see this. This is this A and G are diagonally opposite points.
Yes,
So
sir.
I am just connecting a wire here like this. Wire means I am connecting a cell here. Okay. So now this is just for your understanding that we want to calculate the current between G and A. Okay. So now the challenge is we have many resistances. How many the number of total number of resistance are there?
So just a minute.
12 resistances are there.
Yeah, it's 12.
Because we have 12 edges, so at one edge there is one
Yes, sir.
resistance. Now what you will do, this is suppose the positive end, this is the negative end. Suppose the current is flowing like I current is flowing from here. I am telling you the procedure how you will solve this question. Okay, this is little bit complicated question. You can say that. Okay, so what you will do, just first you will uh, say that the current I is flowing like this, and this uh, from this point there are three branches, one branch, second branch, and other branch, and at each branch equal resistances are connected. Means R is connected at this branch, R is connected here, R is connected here. So accordingly the current will divide. So in this branch the current will be I by 3.
Yes,
Here
sir.
the current will be I by 3, and here also the current will be I by 3. Why the current will be I by 3? Because resistances are equal. Okay, so accordingly
Yes,
you
sir.
can say the current will divide equally. So
Yes, sir.
now this now see, move with the current. Now this current is going here. Now at this point the current, this I by in whole of this wire, the current is I by 3, and at this point the current will again divide in two directions, in this direction
Yes,
and
sir.
in this direction. So
Yes,
this
sir.
will again divide equally. This will become I by 6. This will become I by 6.
I by
Just have a patience. We will get the answer very easily. Okay, just have a patience. Okay, now let's see. Now take this. First we have taken this. Now I will take this. Just move with this here.
yes,
Here
sir.
the current will, at this point the
I
current
by
will
9
divide.
divide.
Not I by 9, because here you can see this. Here the current is I by 3. This
Yeah.
I by 3 is dividing among in between two branches. So you will
Yeah.
write here this I by 6. You will half the current na.
Yes, sir.
If you have
Yes.
three branches, then you will divide the current with 3.
Yes.
Okay.
Sorry.
Okay, just I am telling what I am doing. Uh, this is the current. Okay. suppose here is a resistance R connected, here is a resistance R connected, here is a resistance R connected, here again R, here again R. So if I current is flowing in this and I current is flowing in this, so if you want to find the amount of current flowing in this, so and if the resistances are equal, you have three resistances, so you will divide current by 3. So in each branch there will be a current I by 3. Okay,
Yes, sir.
here you will divide current by 2, so you will get this I by 2. Okay, just now this is very easy thing. Okay, so now we will move in this direction. So let us come to this point. So in this direction again the current will be I by 6. In this direction the current will be I by 6. Now wait and see. Now wait and see. Okay, move from B to F, move from E to F. So this current and this current is meeting at this F.
Yes, sir.
And what will be the current in this direction? I by 6 plus I by 6. So this
Yes,
will
sir.
become
It's two
I by
directions.
3.
Yes.
Here we will add the current.
Yes, sir.
Here the current will be I by 3.
I by 3.
Now move here. Move in this direction. So now come at this point H. I by 6 is coming from here and I by 6 is coming from
I by
here.
3 at the.
I by 3 will go in this direction.
Yes, sir.
Now let us come to point C. I by 6 is coming from here. I by 6 is coming from here. Now what is the current in this branch? Here again the current will be I by 3. And now come at the point G. You will get that I by 3 is coming from here. I by 3 is coming from here. I by 3 is coming from here. What is the current going from here? I only.
I.
So see, I is entering, I is leaving.
Yes, sir.
So what now the thing we have to do, I will choose a path. I will choose a path. We can choose any path, just I am choosing a path. I will
Yes,
choose
sir.
a path for because I will apply the Kirchhoffs voltage law.
Yes,
Because
sir.
without the use of Kirchhoffs voltage law, we cannot solve this. So this is looking complicated. Okay. So I am
Yes.
choosing a path. This ADH, you can choose the path this A, D, H, G, and again come
to
at
A.
So just suppose
Okay.
here is a point K. So just you can say that you are choosing a path A, D, H,
G,
and K, and fit again A. Now we will apply KVL.
Yes, sir.
Actually, this question is very, very famous question. Now apply KVL. Just start applying KVL.
Yes, sir.
From
It
K
is in the
to D.
direction of the current will be minus.
So we will take minus I by 3 into R.
Yes, sir.
Now it will become very easy. Now from D to this.
Minus I by 6 into R.
Very good. Into R. From here
minus
to here.
I by 3 into R.
Into R.
That's it, sir.
I by 3 into R. Now and from here to here there is one cell only we have. Suppose
yes,
I am supposing E is the EMF of this cell. So
okay, plus
when
E.
you will move from this path, you are moving
yes,
from lower
E.
to higher. So it will become plus E. Okay,
plus E.
It will become plus E. And according to KVL, summation of all the voltages is equal to 0.
Yes, sir.
Okay, very good, fine. So now, can you calculate this? You will take if you will take the LCM 6. Here you will get minus 2 IR.
Yes, sir.
Here you will get minus IR.
Minus IR.
Here
minus
again you will get
2IR.
2 IR, and this is plus E is equal to 0, and this will
It
become
will be minus 5IR by 6 plus E.
minus 5 IR divided by 6.
6
And
plus E.
again, if you will take this side, this minus will cancel out.
Yes, sir.
And just take the ratio of voltage by current, total voltage, total current, and you will get this as the equivalent resistance. When you will calculate from here, this E divided by, you will get 5R by 6. So this is your answer.
Yes, sir.
So in this way also you can see how we have calculated the equivalent resistance.
Yes, sir.
We cannot think that we can calculate that the equivalent resistance among these two. This is the method now. We are
Yes,
just
sir.
applying this R equivalent equal to total voltage. What was the total voltage? Total voltage is E.
E
And what was the total current? Total current is I.
I.
So we have calculated E by I, and we have just from here I have calculated E by I. Okay. This
Yes,
E,
sir.
under this E, the I will come here. Under this E, when you will solve it further, you will get E by I, you will get 5R by 6. And this E
6.
by I is equal to R equivalent. So R
Yes, sir.
equivalent of this circuit is equal to 5R divided by 6. So this is the answer, and in this way you have to solve. And one thing more I want to tell you, depending upon you, you can choose any diagonal points. F and D are also diagonal points, A and G are also diagonal point, B and H are also diagonal point. And one thing more, you can choose any path,
Yes, sir.
but your answer will be same. So just please note it down. And mark 1 star on this. After this, we will have very interesting topic. Very interesting. Harsh,
Yes.
are the things getting out of your mind, or
No, sir.
is it
No.
is
It
all
is,
the
sir.
things controlled? All the things controlled
Yes, sir.
in a
Yes.
controlled manner, because we are studying this. One thing I want to tell you, that if you will solve the question step by step, then you will not get confused. If you will think that I will solve this question in 1 second and in 1 minute, then that is not possible for each and every question. There are some question like this. These question will always take some time.
Yes, sir.
Yeah, step by step, if you will follow, then things will become easy. Otherwise, you will get confused. Harsh, should I scroll down?
So just a minute.
Okay, fine. You can take time, because this diagram is little bit typical.
Yes, I can scroll down, sir.
Yeah. Here are so many directions of current. Just give me 1 minute and just. This chapter is going to end.
Yes, sir.
I maybe this will end today. This diagram is looking beautiful now.
Yes, sir. Second new scroll down.
Have you completed this circuit?
Yes, sir.
Oh, fine. Just note it. In this question, the main thing is understanding the diagram and understanding the direction and the magnitude of current. Okay, and after applying the KVL, see the condition of the question. And the unit of resistance is ohm. Okay.
Ohm.
Yeah. Harsh, do you know Hindi?
Yes, sir.
The assignment question that I am taking these days are very, very important questions. Very, very important.
Yes,
If
sir.
you will follow it, follow that, then it is going to help a lot.
Done, sir.
Fine. Now we have a this is completed now. Okay. We have just applied here this concept R equivalent total voltage, and also we have applied the KVL, because without can you solve, we cannot
No,
solve
sir.
this question without applying the KVL. Okay. And now we have studied the Wheatstone bridge already,
Yes, sir. Yes, sir.
and Wheatstone bridge I have told you just where is the Wheatstone? This is the Wheatstone bridge, not this. This is the Wheatstone bridge I have told you, and at that time I have said that if this bridge is balanced, this condition will be followed. Okay, this
Yes,
condition
sir.
will be followed if there will be no current in this R5 or in this wire. So this R1 equal to R2, R3 equal to R4. But I have not derived this condition from where this result has appeared. Okay. So today you will know that from where this result will appear. Okay. Just see this. Okay. Do you want to relax for 1 or 2 minutes?
No, sir, it's fine. I can continue.
Okay. If you want, then you can tell. Okay. Now, we have to prove the Wheatstone bridge. And what is the Wheatstone? Wheatstone bridge is this. One resistance is connected here, another resistance is connected here, another is connected here, another is connected here. Suppose this is R1, R2, R3 and R4. R3 and R4. And now this time what I am doing, I am just connecting a galvanometer here. Galvanometer is a thing which is used to measure the current.
Yes, sir.
Okay. Galvanometer. I am just connecting galvanometer. So I am taking this point as A, this point as B, this point as C, this point as D. And the whole thing I am connecting with some cell or battery. This is the Wheatstone bridge we have. And we know that this condition will be valid. R1 is equal to R1 divided by R2. R3 by R4 is the balancing condition. And this balancing condition will be valid when there will be no current in the galvanometer. When no current in galvanometer. Galvanometer. So what we will do here, this can be proved. This can be proved with the help of Kirchhoffs voltage law. Kirchhoffs voltage law is very important. Okay, you can prove each and everything. So Kirchhoffs voltage law means now what I am going to do here. Now I am just proving it. So I am supposing from first thing what we are doing when we are applying the Kirchhoffs voltage law. First we are just defining the current in the circuit by ourselves. First we are just defining the current in the circuit by ourselves, and after that we are applying the Kirchhoff voltage law. So just first define the current. So I am just supposing I1 current is flowing here. I1 current is flowing through this AB. Okay. Here also the current will be I1. And now this is the junction point. This B point is the junction point. Some current will go in this direction and some current will go in this direction. Suppose IG current will be here, is going in the galvanometer. From this I1 current, IG current is going in the galvanometer and remaining current will flow in this resistance. What is the remaining current here? I1 minus IG
I1
will be the
minus G.
IG. Okay, very good. I1 minus IG. So here the current is IG. Again, here is the current IG. And one thing we have to also assume that here, suppose actually who is giving the current, means which device is giving the current. This device is giving the current, na? This device, this I current is flowing like from here, na? I current is flowing from here. So from this I, I1 current is flowing in this direction. This I current is from this cell, and this is the junction point. And from this junction point, suppose I1 current flows in this resistance, and remaining current will be in this resistance. So what is the remaining current here? I minus I1.
I minus I1.
Okay, very good. Now check. This current is coming in this direction, and this current
Yes,
is coming in this in this direction. So at this junction point, all the current will meet. So what is the current in this direction?
Yes,
The
sir.
current in this direction will be I minus I1 plus
I1
IG.
plus IG.
Why we are doing plus? Because both are in the same direction.
Yes, sir.
Okay. Okay. Now this is the same current will flow here, and now you can see here, this current is coming in this direction, and this coming is current in this direction. When these currents will meet at this point, you will add all the current, you will get the same current I. If you don't believe me, just add. This
No,
is
sir,
I1 minus
I solved
IG.
this, sir.
Okay, very good. Plus I minus I1 plus IG. Now you can see this IG gone, and this I1 gone. So I current is. Okay.
Yeah.
So actually, what we have done, I have just applied the Kirchhoffs current law. Okay.
Yes, sir.
Okay, but Kirchhoffs current law is not required much. So now what we will do? Now we will apply the Kirchhoffs voltage law in this loop and in this loop. Okay. Now apply the Kirchhoffs voltage law in path A B, in loop A B D A. A B D A. Okay.
Yes, sir.
So you are choosing path A B D A. This is A B D A, and just apply KVL. Apply KVL. So apply KVL. This will become. I am just taking this diagram here. No need to note this diagram again and again. I am just taking it for the simplicity of calculation.
Yes, sir.
I can copy. You cannot copy. You do not have the option of copy in your copy. Okay. So just apply the KVL. From A to B, what you will write? Minus I1 into R1. I1 into R1. From
Yes, sir.
From B to D, you will write IG into G, and G is the resistance of galvanometer. Just write here.
Resistance. Yes, sir.
G is represented as the resistance of galvanometer. Okay. So okay, fine. So what you will write? You will write minus IG into G, and from D to A. From D to A, you are moving in the opposite direction of current, so you will write plus I minus I1 into R3. Okay. So we have applied, and this is equal to 0 now. Is it fine or not?
Yes, sir.
Are you getting now? I have just applied the KVL
Yes, sir. Yes, sir.
in this loop, in this direction, you can say.
Yes, sir.
So now we already know that this IG is equal to 0. This IG is equal to 0. We already know that. If this will be the balancing condition, then IG will be 0. So put IG is equal to 0. I suffix G is equal to 0. So you will get I1 into R1. This IG you will put 0. So this whole term will become 0. So this will become plus I minus I1 into R3 is equal to 0. So from here you will get I minus I1 into R3 is equal to I1 into R1.
R1.
So from here you can get I minus I1 divided by I1 is equal to R1 divided by R3. This is equation 1. This equation we have got when we have applied the KVL in this loop. Now we will apply the KVL in this loop. Okay, just apply the KVL in this loop. In which direction? Just choose any direction. Just choose this direction. Okay, and now choose some another point. Don't take a which point do you want to choose now? From which point do you want to start?
Sir, C.
Okay, fine. See, and in which direction do you want to go? Suppose you are going in this direction.
CB,
Okay.
CBD.
CBDC.
Yes,
CBDC. Path CBDC and apply KVL. Kirchhoffs voltage law. So now apply. So we have path CBDC. CB in CB, what you will write? Plus I1 minus IG. I1 minus IG into R2. And when you will move
Yes, sir. Plus I1 minus IG.
BD, BD you will write minus IG into G. Minus
Sir,
IG.
you're lagging, sir.
My voice is lagging. Just wait.
Yes, sir.
Hello. Now it's fine.
Yes, sir. Now it's fine.
You can tell me if my voice is lacking or whatever. Okay, this is Ig into G. Why we are why I have taken negative sign? Because we are moving in the same direction of current.
Yes, sir.
Now apply in DC. Apply in DC. This will be minus I minus I1 plus
IG
into R4, and all the things equal to 0.
Yes, sir.
All the things means the voltage equal to. So put Ig again equal to 0, because we know that there will be no deflection in the galvanometer. So you will get I1 into R2. And when you will put this Ig equal to 0, here also you will get 0. This is removed. Here when you will put Ig equal to 0, so here you will get minus I minus I1 into R4 is equal to. So from here you will get I1 R2 is equal to I minus I1 into R4, and you can say that I minus I1 divided by I1 is equal to R2 divided by R4. Okay, so this is your equation second. Now compare equation 1 and compare equation 2. Compare equation 1 and 2. Compare equation 1 and 2. When you will compare, you will find that this thing and this thing both are equal. So if this thing are equal, then this thing and this thing will be equal. Means R1 by R3 means R1 by R3 is equal to R2 by R4, and we can modify this. I can write R1 by R2. See this. This is R1. This R2 will come in the denominator, and this R3 will go here.
By R4.
So R3 by R4, and this is the proof. And this will appear in your examination, that they will say that prove the balancing condition.
Yes, sir.
So in this way you have to prove it, and just please note it down.
Yes, sir.
we will have one topic, that is meter bridge.
Yes, sir. In which we have to move the jockey over the wire,
Yeah,
metallic wire,
very
right?
good, very good, very good. Harsh, have
Yes,
you
sir.
completed this?
Yes,
Or
sir. Yes, sir. You can scroll down, sir.
okay, you can ask me. And please don't make it again and again this figure.
No, no, sir. I just meant
It will take your time. So now if the question will appear in the examination, proof the balancing condition, then you can
So
solve
can you
now.
scroll up? Yes, sir. Can you scroll
Just,
up?
yeah, just I am just doing that. Actually,
Yes.
there is a problem here. So just give me a minute. What has happened here? Just wait.
Yes, sir. Yes.
Actually, this is not going side. Okay, just write it.
Yes, sir. Now it's
From
okay.
here, na? It's
Yes,
fine.
sir. So can you show the path?
Okay. This na?
Yes, yes. Yes, sir. Now you can scroll down to this. So can you scroll down?
Yeah. First, do you have organic chemistry?
Yes, sir. Yes. I have.
Which chapter you are studying in that?
Sir, alcohol, phenols, and ethers.
Alcohol, phenol, and ethers. Okay.
Yeah.
It is after the aldehyde and ketone and before the aldehyde and ketone.
It is after halogens and aldehydes.
Acha, acha. Okay. Good.
Done, sir.
Fine. So next topic is the potentiometer. But this potentiometer is not the part of your syllabus now. You can see this. This is not the part of your syllabus from this year. So, okay.
Yes, sir.
So no need of this. So we have meter
Yes,
bridge.
sir. No need. Yes.
Meter bridge. So meter bridge is very simple.
Yes, sir.
Meter bridge is very simple, and meter. What is the use of the meter bridge? First, I will write some theory, and after that, I will explain. So, meter bridge, you can say, is the practical application of Wheatstone bridge based on the, you can say, based on the practical application of Wheatstone bridge. Wheatstone bridge. And another point is this is used to calculate the unknown resistance. Actually, I think that there will be experiment also in your lab.
Yes, sir. There is an experiment. We have done it.
In school, used to calculate unknown resistance. Okay. And if the examiner asks that what is the principle, so for the principle, it is based on the principle of balancing of Wheatstone bridge. It is based on the principle of balancing Wheatstone bridge. What is the meaning of wheat in Hindi? Do you know? And what is the meaning
Yes,
of stone in Hindi? Tell me.
I just forgot the names. Sir.
What is the meaning of stone in Hindi?
Sir, Patthar.
Patthar, yeah, of course. So this is something Patthar. Actually, this is not Patthar. This is the name given. Someone given the name, so that we are following. So this is based on the. It is based on the principle of balancing Wheatstone, balancing of Wheatstone bridge, or you can write balancing Wheatstone bridge. Bridge, na? Why they are calling it as bridge? Because there is a bridge.
Yes, sir.
Fifth resistance is a bridge. Okay. So already discussed many times what is the balancing conditions. Again discussing.
R1 by R2 is equal to R3 by R4.
Yeah. But this is R1, this is R2, this is R3, this is R4, and here I have connected a galvanometer. Okay, and suppose this is a point A, this is a point B, this is a point See, please remember all these points. These points are very, very important. And what we will do, we will just connect this with some power source, DC power source. Okay. And the balancing condition will be R1 divided by R2 is equal to
R3 by R4.
3 by R4 when current in the galvanometer is equal to C. This is the condition that we will follow. And now I will tell you how the Wheatstone bridge we will make in the examination, or you can say the construction of Wheatstone bridge. Very, very simple construction.
Sir, I guess you wrote it.
What
So it
theory?
should be RUC, right?
R? Oh,
UC.
sorry. Sorry for that. TRUC, TIUN, construction. Okay, fine. So
Yes,
in the
sir.
construction, just see this. What I am going to do here. These are copper strips. These are copper strips. And suppose we have connected our resistance in between this point and in this point we have connected resistance, and one thing here, we have just connected a wire here. This is the wire we have, straight wire we have, and I am supposing this point as A point, okay, and this point as B point, and this point as C point, and just see this. Here we will have a galvanometer, and this galvanometer is connected with a jockey.
Yes, sir.
Jockey is nothing. Jockey is, you can say, for making the temporary contact. For making the temporary contact, this thing is known as the jockey. Is like, you can say, this type of pen you touch there, and so just I am telling all the things. So this is jockey, and here resistances are connected like this. Okay, and jockey is used to make temporary contact. Temporary contact with what? With wire. Okay, temporary contact with what? With wire. And what will happen when you will do the experiment of this type of combination you have, and in your
Yes,
hand
sir.
there will be a, and you will move jockey across the length of the wire,
Yes, sir.
and there will be a point,
You get zero
there
galvanometer.
will be the current in this galvanometer. Okay,
Yes,
suppose
sir.
this is a point D. Okay, there will be a point where, and what you will do, you will measure the length of this point
Yes, sir.
from this end point or 0 point. Suppose this is L. So, and you will take this wire of 100 centimeter length.
Yes,
The
sir.
length of this AC wire is 100 centimeter. If this is length L from A to D, is length is L of the wire, then from D to C the length will be 100 minus L.
Yes,
This is
sir.
simple maths. Okay, fine. Okay, and we already know that in a wire we can calculate the resistance according to length and area, rho L divided by
Rho
A.
L by A.
It means rho is the resistivity of this wire, L
Yes,
is the
sir.
length of this wire, A is the
A
area
is
of
the
this wire.
area of
Here
cross.
what will happen? Here what will happen? As the wire is same, if I am talking about the resistance of this length L, if I am talking about the resistance of this length L, suppose R3 is the resistance of length L and R4 is the resistance corresponding to the length 100 minus L. So,
Yes, sir.
so the length of the wire have some resistance according to this formula. So we know that if I want to calculate this R3, so I will write rho L3 sorry, rho L divided by A, because the area of cross section is not changing. Area of cross, if A is the area of cross section of this wire, rho is the resistivity of this wire, then R3 can be written like this, or
Yes, sir.
you, so, and R4 can also be written like the rho. What is the length? 100 minus
100 minus L.
A. Area will remain same. Area is not changing. So fine. Fine. When you will get the balancing condition, for balancing condition, what you will do, what the balancing condition, just see this. In between A and B, there is R1. In between
Yes, sir.
A and B. And this, if this point is A, na, this point is A means the potential of this point is A. If you are moving on this wire, the potential of this point is also again VA. Okay. So
Yes,
you can
sir.
suppose this point also as A, or you can suppose this point as also as C. Why? Because on the wire, on the conducting wire, the potential remains same. Okay, so between A and B, the resistance is R1. Here, A and B resistance is R1.
Yes,
Between
sir.
B and C, between B and C resistance is R2,
R2.
and between A and D resistance is R3.
R3.
Between D and resistance
R4.
is R4. So for the balancing condition, you will write R1 divided by R2, R3 divided by R4. Okay. So
Yes.
we have R1, we have R2. What is the value of R3? R3 you will write
Rho
this
L by A.
rho L by A. Rho L by A, and what you will write for R4? Rho L,
Rho 100
rho
minus
100.
L minus L by A.
Someone is saying something. Okay. Someone asked me to leave the class at 9. Okay, I will leave the class at 9. No problem.
Sir, I didn't ask you, sir.
You don't ask, you know, someone else
Okay,
from
okay.
from the company side.
Okay, sir.
Okay. So rho and this is A na here. Here you will write. So
Yes,
you
sir.
will get this R1 by R2 is equal to this A and A will cancel out. This rho and rho will cancel out. You will get L divided
L
by
by 100 minus L.
final result. If you do not know any of the resistance from R1 and R2, you can get. So just please note it down.
Yes.
In 5 minutes. Someone has given me the order that I should leave the class at 9.
Second is scroll down. Yes, sir. We can start from construction, sir. Can you scroll down?
Okay. And this is the simplest construction. You will get full marks when you will draw this type of thing.
Yes, sir. Yes, sir.
Believe me. You can get many types of construction in books and all that. No requirement of that. You can just draw this
Yes, sir.
and you will get full marks. So unfortunately, we have to leave the class at 9. And we have
Yes,
just
sir.
one last class. What we are going to do, we have few numericals only. Few numericals
Yes,
only.
sir.
Two numericals on this because those numerical can be asked in the exam. So that is why I will I will solve those two numerical. And after that, we have very small topic heating effect of current and one numerical, and this chapter will be finished forever.
Yes, sir.
Harsh, assignment questions are helpful for you? Means that in the starting
Yes,
that
sir. Yes.
we are solving the some questions of previous year question of CBSE, and I think that those questions are very much helpful.
Yes, sir. Second, hold on.
I am zooming out.
Yes, sir.
So today's lecture was easy or hard or medium?
Easy.
Everything is easy. Yeah.